So in ionic bonding, we're able to predict the proportion of elements that will be found in the compound. And so we'll be able to write chemical formulas for ionic compounds. Chemical formula is defined right there. You can read through it. It says it depends on valence electrons. And again, shows the proportion of the atoms, not the exact numbers. Okay, and no, you don't have to be able to draw these, but I do want you to follow what's going on so you understand where this is coming from. So if we have we want to have the compound calcium fluoride, or we have it, we want to figure out what proportion of calcium and fluorine atoms we'll have. So here's a calcium atom and 2 fluorines. Calcium has 2 valence electrons, and it will give those up, but each fluorine can only take 1, so we'll now have calcium with a positive 2 charge because it's lost 2 electrons, and 2 fluorine atoms, each of which has 1 negative 1 charge. And because of the opposite charges, they'll attract each other and arrange themselves into really a large lattice where calciums will be surrounded by fluorines and fluorines by calciums. And the ions are charged. Okay, here's sodium and chlorine. And sodium has 1 valence electron, chlorine has 7 and would like to gain 1. And in fact, it will do that. There it is. It's gained 1. It now has a negative 1 charge, and the sodium has a positive 1 charge. So it takes 1 sodium for every 1 chlorine. So in writing the formulas, you see that because we had 1 calcium for every 2 fluorines, we write the formula CaF2 because it's 2 fluorines for 1 calcium. In this case, we have 1 sodium for every 1 chlorine. So the formula is just Na for sodium Cl. Here's a few more examples, and I'll talk through them. So here's magnesium. Magnesium has 2 valence electrons. We want to know how it'll bond with bromine to make magnesium bromide. So here's a bromine. Bromine only can only receive 1 electron because it has 7. So it could receive that one, but then what about the other one? Well, we need another bromine, and so the second bromine can receive that. And now we'll need 1 magnesium for every 2 bromines, so the formula will be MgBr2. Now, one question that comes up here is how do you know whether to put the magnesium first or the bromine first? When we've written out the name of the compound, they're always going to be in the order that the formula is written, but sometimes they're not written as the name of the compound. And so in that case, you look for which one is going to produce a positive ion. And magnesium, because it loses its electron, will become positive. The positive goes first. Okay, here's potassium. Now, potassium only has 1 valence electron, but it wants to bond with oxygen. Oxygen needs 2 electrons in order to have an octet, right? Have the 8 electrons in its outermost energy level. So we need another potassium. And so that'll take 2 potassiums for every 1 oxygen, and we'll write K2O. And now we have aluminum. Aluminum has 3 valence electrons. If it bonds with chlorine, each chlorine can only take 1, so it's going to take 3 chlorines to bond with 1 aluminum. So the formula then will be Al, because aluminum is positive when it loses its electrons, and Cl3, 3 Cls.